Hello and welcome again to our channel Bit Astro. So here I am Suraj again with a new video of mine on the second part of the ordinary differential equations, which is the second method for solving the ordinary differential equations called the exact differential or exact ordinary differential equations. So what's this type of thing is we are going to discuss here. As in the first video, we have discussed about the separable solutions. So in this video, we are going to discuss about the exact ordinary differential equations. So now let's start that what exactly this is. So suppose that the differential equations is of this type exactly. Okay, so if a differential equations is of this type, how we can solve this types of the differential equations? So first of all, these types of differential equations, you can see that a is a function of x and y and b is a function of x and y. So in the partial differentiation, you have heard that this expression is the expression of the differential of an particular function. It means if you have studied about my lectures on the partial differentiation, this is a differential of a function, and the differential of a functions can be represented in this form axy, and here is dx, and plus here bxy, and here is dy. So the differential can be represented in this form where du is equals to the 0. Okay, so du is equals to the 0. So here it means that du x and y is also equals to the 0. Okay, so this is thing. So this is a differential. So what is differential? I have discussed about, so you can watch those videos where I have discussed about the differentials. So suppose that this is a subfunction. This is a type of a particular differential equation. How we can solve this? So first of all, you have to check that this particular differential is an exact differential or an inexact differential. What is exact and inexact differential? So again, you have to watch my previous videos in which I have discussed about the exact inexact differentials. Okay, so the exact and inexact differential conditions are like that. So when you take the partial derivative, okay, so this is very important. So when you take the partial derivative of the a function with respect to the y, and it is equals to the partial derivative of the b function with respect to the x. So if this condition is true, suppose that a function can be anything x square y. So if you differentiate it with respect to the y, and b functions can be anything. So let's take an example, okay, so that you can understand it better. So let's take an example of this thing. So an example is suppose that I've taken a differential equation which can be written as like xy square dx, and plus, so this is just an example, okay, so I'm taking it to explain that exact and inexact difference. So this is exact differential, that what's this condition is. Plus I can take yx, okay, yx dy is equals to the 0. So this is a form of the differential equation that I have written here. And remember, this particular thing is very important, because to solve these types of equations, first of all, you have to check that is this given differential equation exact or not. So let's check in this example. So this is a, this is particularly a, and this is particularly b. Okay, so we have to check this out. Suppose that I differentiate it with respect to the first. So first of all, to fulfill this condition, let's differentiate it. So the differentiation of this particular function with respect to the y will what? So this is a partial derivative form, and this differentiation. Okay, so this is equals to the 2xy. 2xy is equals to the partial derivative of the a with respect to the y. Okay, and again we have to do the partial derivative of b with respect to the x. So what our equations will become is that y can be put out at, okay, so this is equals to the y. So from this scenario you can conclude, from this scenario you can conclude that the del a upon del y is not equals to the del b upon the del x. It means the differential equation that I have written here is not an exact differential equation. So you remember that a differential equation can be exact, like this form of differential equation, and this form of differential can be exact even when you, the first function which is a can be differentiated with respect of the y, and another b function can be differentiated with respect to the x, and if these are equals, then we can say that the particular equation, differential equation, in an exact. Okay, so this is an inexact. Maybe there is some sorts of functions which can be exact. So to make this particular function exact, what we can do is that we can just do okay, so these equations can be made by exacts by the various methods. Okay, so we will discuss in the next video that how can we do the solutions of the inexact ordinary differential equation. So what is inexact? So just like this is exact, this is exact differential. Okay, but this particular condition is inexact. Okay, inexact differential. So the solution of this types of differential equations I will cover in the next video. So for now, let's take that how we can solve the particular type of the differential equations in which its a and b functions are equal when we differentiated it with respect to the y and with respect to the x respectively. Okay, so how we can do this? So if this conditions fulfills, so if this particular condition fulfills, how we can find out this solution? So if this condition fulfills, our solution uxy can be represented as like this. So uxy can be represented as the integral of a. Okay, so the integral of a xy and here dx and plus the integral of our b part which contains everything but not x. Okay, so it's I will explain this second part. So to find out the solution, and you remember that solution is a constant. So the solution of this types of differential equations can be determined by uxy is equals to integrating the axy dx. So I will use another pen. Okay, so integrating axy, it means first function with respect to the dx and plus second. So what I will read here, so in the second integrating things, what you have to do is that you have to choose any other particular function. Okay, so any other particular any function that contains that contains contains no n, that contains no x. Okay, so this is the thing, that in the second and integrated with respect to the y. So the thing is that in the second integral sign you have to choose your second. Okay, you have to choose your this particular this particular function, but neglecting the x. You do not have to choose the x, you have to only choose the b as a function of y, or if b contains any type of the constant, you have to just remove the x. For suppose that if this is our b function, in this integral sign we only put y. So for this scenario I've been explaining, so for this scenario, so relating this and this scenario, we can integrate only y dy. We just neglect the x term. We just neglect the x term and we already write y dy, or maybe some other constants that there should be in the b. So that's the thing that you can find out the solution. So this is the method to find out the solution of this types of differential equations, which is exact differential equations, we say this type. How we can find it? So the solution uxy can be calculating by the integral of the first term, including both x and y, but integral in the second. But when you do the second functions integral, you have to remove the x. Just like here, I have not chosen x, I only chosen y dy. Okay, that's why we have to choose this, and this is a method for solving a differential equation which is exact. But what differential equations can be solved by inexact? So we can solve this particular things here, and we will see those types of particular differential equation solutions in the next video. So this is our video where I explain about the exact ordinary differential equations, how this exact differential equation forms, and these types of things. So in the next video, maybe I will explain this particular thing with the help of the examples and some of the good questions related to the exact differential equations. So thank you for watching my video on this particular differential equations exact.